know you Gretas and Chutezcats out there. Welcome to APES Notes, Unit 4, Section 6. We're getting into watersheds. So we're going to, here's Indiana watersheds. Most of rain that falls in Indiana ends up in the Wabash River. So if you think of all the tiny little streams going into bigger streams, into rivers, they're all going to end up flowing to one place. Remember, in Nemo, all water, all drains leads to the ocean. So all of these things are going to come together. So this is one watershed. There's a video I'll put, there's a link to a fun game. It's for kids, but your kids. Just play this for a couple minutes if you want. It's a nice introduction to watershed. I will have the link on Canvas for you. We're going to watch a super quick video on what is a watershed, and then I'll keep going.
What is a watershed? Is it a shed that holds water? Try again. A watershed is all of the land that drains into the same location or body of water. People tend to think only of water bodies such as rivers, lakes, and wetlands as being part of their watershed. However, any land, whether it is park, farm, forest, school parking lot, and even the soil we build our homes on is also included. Think of a watershed as a funnel, collecting all the water within a specific area and draining into the nearest body of water. Drop by drop, water is channeled into soil, groundwater, creeks and streams, making its way to larger rivers and eventually the ocean. Everyone in the world lives in a watershed. Watersheds know no political borders, whether local, national, or international. Our environment, our economy, and our society all depend on a healthy watershed.
All right. Okay, moving on. So we have 6 characteristics of a watershed. This is going to go on page 27 in your packet, and we're going to go into detail on each one of these now. So the first one is area. This is going to reflect the volume of water that can be generated from a rainfall. It references the drainage basin of the watershed. So when you talk about the drainage basin, that's the whole area. Length. Length can be measured in different ways, but it's generally considered the principal flow path of the watershed. Slope. Slope is going to affect momentum of runoff, as well as affecting the velocity of overland flow, watershed erosion potential, and local wind system. I don't think it would be notes if I didn't yawn at least once. So there's your slope. Soil, we're going to address in one more page when we get to types of watersheds. Vegetation, there's a bunch. So vegetation is going to add the organic matter to the soil. So we have our sand, our silt, and our clay, and then the vegetation is where all of that organic matter comes in. The tree litter is going to help protect the soil surface from losing topsoil, from losing nutrients. The roots will prevent erosion. The canopy keeps the water cool to prevent thermal pollution. The warmer water gets, the less oxygen is in the water, and that is really bad for all the critters that live in the water. The canopy will also reduce the force of rain and wind velocity. And then plant cover provides both food and protection for organisms. And then we have what is called a riparian zone, and this is going to help buffer the water from runoff, so sediments, chemicals, and nutrients. So you have your upland area, you have your riparian zone, and then you have your aquatic zone. So this is going to help kind of filter stuff out before it gets down to the water. And then we have what are called divides, and divides are kind of these top parts. These are the peaks and ridge lines with lines connecting the highest points. So the divides are going to divide the different watersheds. So on the other side of these mountains is a different watershed. All right, so your watershed classifications. You can have agricultural, and these are fairly barren fields, compact soil, less infiltration, fewer streams, and a lot of application of both fertilizers and poop changes the structure of the land and the watershed because all of that chemical gets washed into the water. Urban areas have a natural water flow pattern that has been massively greatly altered. Tons of runoff because we cover up everything that absorbs. all of that great soil that would absorb, we put concrete on top of it, which means lots of runoff, and we're fairly vulnerable to flooding. We have a fixed land use, but the precipitation changes all of that. So you can see all of this awesomeness versus a lot less. Mountains, very steep gradient, less porous soil, much more rocky, less infiltration, very high runoff, and downstream areas are often vulnerable to flooding. Forest, the evapotranspiration is very dominant, so that means most of the water in a forest is coming out of the plants. It's evaporating or transpiring out of all the leaves. Very high infiltration, very little runoff. It gets absorbed. And here's a picture of you have snow runoff, stream runoff. It gets absorbed down into groundwater, goes to a lake, evaporates up, transpires up. Desert has fairly sandy, porous soil, very little rainfall, so we don't really have many streams in the desert, and limited groundwater recharge. So the little water you have isn't getting replenished. Goodness. All right, coastal, high rainfall, no real channel control, lots of local flooding, high water table, and what is called saltwater intrusion, where the saltwater gets pulled in and then it's in this area. A wetland, water is definitely not a limiting factor here. We have lots of high rainfall, high runoff. Dominant thing is going to be evaporation. Wetlands are great for absorbing a lot of water, so we need to not build over wetlands around cities because they're going to help prevent floods. You often are going to have a mixed area. So you have a reservoir, you might have some tributaries, you have a farm area, you have an urban area, you've got river, and estuary is where that fresh and salt water are going to mix. So think about what effects dams can have on watersheds, and there's 4 big ones. Before the dam, upstream of the dam, flooding is going to be a factor. Downstream of the dam, you're going to have a reduced water flow and a lot less sediment, which is good for farming. So any farms that existed downstream of a dam just got massively screwed over because they're not getting as much water and they're not getting all that nutritious sediment. Temperature changes can also affect the growth of organisms, because if you think the average temperature of this water versus the average temperature of this water are going to be very different. And it's going to also prevent fish migration. So we get cool things like fish ladders and fish cannons. Look that up on YouTube. It's kind of cool. So 4 big things that dams can impact watersheds. So what would make a floodplain a popular area for human settlement? This works so much better when we're doing this in class. So this flat area is super nifty to live on. It's very fertile soil because it gets flooded. So all those sediments go out, all those nutrients. As well as you can build your house right here, and you're very close to the river for transportation. So even though it floods, people tend to settle there anyway. So what factors need to be considered when building housing on a waterway? There's 2 big things. You want to see what the land use upstream is, because you don't want that affecting you negatively. If you live downstream of a big farm, all those nasty nutrients that are washing in are going to be affecting you. You also need to think about the effects of the water on water quality downstream when you have your house. So don't be dumping chemicals here to affect the people downstream. There's a really cool video on the source of life, and there's questions that go along with it in your packet. The link to this is in the packet on Canvas, so you can get it there and watch that. And we have ended the notes, so you have survived yet again. Before we go, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.